Alright, let's go ahead and take a look at the review for Chapter 4. Let me get some gridded paper here. Okay. Alright, so the first problem is quite a lot we have to do. So the first problem, we have y is equal to negative x squared plus 6x minus 8. And we want to essentially graph this, but first, let me go through each of them. So A asks us if so this is a standard form. A is -1, B is 6, C is -8. Alright, so A says, does the parabola open up or down? Well, the A value is negative. It's negative x squared, so this is going to open down. B, state the coordinates of the vertex. So the vertex is found in standard form by using the formula -b over 2a to find the x coordinate and then substituting that into the problem to find the y coordinate, and that will give us the vertex. So our vertex, the x coordinate, -6 over 2 times a, so -2. So the x coordinate is 3. So the x coordinate of the vertex is 3. Now let's substitute that into the equation to find the y coordinate. So you got -3 squared plus 6 times 3 minus 8. That's -9 plus 18 minus 8. So that's -9 plus 18 is 9 minus 8 is 1. So the y coordinate of the vertex is 1. So the vertex is 3, 1. C, state if the vertex provides a minimum or maximum value and then give the minimum or maximum value. So the vertex, if we think about what this is going to look like, it's going to look like this, and the vertex is going to be here at 3, 1. So that's going to be a maximum. And the value of the maximum is always the y coordinate, because the y coordinate measures how high it is. So that's at 1. So the y coordinate equal to 1, that's the maximum. D. D is give the equation for the axis of symmetry. Well, the axis of symmetry is just the x coordinate, so it's a straight line x equals 3 right here. E, state the coordinates of the y-intercept. So the y-intercept is always, in standard form, it's the c coordinate, or the c value. So the c value is -8. So the y-intercept is 0, -8. That comes directly from the c value. F, give the domain. Well, the domain of any quadratic is all real numbers, -infinity to infinity. G, G is the range. Now the range, if we look at the little sketch I made, we can see that it goes down and then it comes up to the maximum, which is at 1. So the minimum value is going to be -infinity because it goes down forever, but the maximum value is going to be 1 because it stops at 1. So the range is from -infinity to 1. H, graph it. Okay, my graph's not really that great. I'll graph it over here in a second. I, state the zeros. The zeros are the x-intercepts, which are the solutions, and there's a couple of ways to find the solutions. One of the ways to find the solutions is by factoring. Another is to use the quadratic formula. Another is to complete the square. I'm going to factor this one to find the solutions. So first of all, the first term cannot be negative, so I'm going to factor out a -1. It's going to give me x squared minus 6x plus 8. And then I'm going to use the x to factor this. So this factors into, so positive 8 up top, -6 in the bottom. So the two numbers I'm looking for are -4 and -2. -4 times -2 is 8, -4 plus -2 is -6. So this factors into -1, x minus 4, x minus 2. So I can see that my zeros are my x-intercepts, in other words, are 4 and 2. So the zeros, x equals 4 and x equals 2. You could have found that by using the quadratic formula. You could have found that by completing the square, or you could have found that doing it the way I've done right here. However, you did need to factor out the -1 in all cases. Well, most cases you would have needed to factor out the -1. Sorry, the y shouldn't be there. It should be set equal to 0, because when you're looking for the x-intercepts, you're solving this equation, 0. So yes, you could have done this by completing the square, you could have done this by quadratic formula, or by factoring, but in all cases, you needed to divide out the -1. You could have factored it out, or you could have divided it out just straight up. Alright, so let me use all of this information I've got to graph this. Alright, so first I'm going to graph the axis of symmetry, so that's x equals 3. Geez, it's hard, very hard to see. So I'm going to count 2 spaces to 3. So x equals 3. Jesus, these are too small. So there's my axis of symmetry. My vertex is going to be on there somewhere. So my vertex is at 3, 1. It's like right here. My x-intercepts are at, well, my y-intercept is at 0, -8. 1, 2. So it's somewhere about right here. So I can reflect that onto the other side, somewhere over here. The x-intercepts are at 4 and 2, so like right here and right here. So I'll graph my quadratic, and it looks something like this. Doesn't have to be perfect. Mine is very, very far from perfect. So something like this, and the gridded paper is not doing me any good. Okay, so that's number 1. Alright, number 2, y is equal to x plus 2 squared plus 1. Alright, I'm answering all of the same things here. A, I want to know open up or down. Well, the a value is 1, so it opens up because it's positive. B, the coordinates of the vertex. Well, this is in vertex form. This is in vertex form. So vertex form is y is equal to a, x minus h squared plus k. So the vertex is going to be the opposite of this value, comma this value, because that's minus. So that's going to be -2, comma 1 is the vertex. C, state if the vertex provides a minimum or maximum. Well, this is going to be opening like this, so the vertex is going to be down here. It's a minimum. The minimum value is the y value, so it's 1. D, give the equation for the axis of symmetry. Axis of symmetry is the x-coordinate of the vertex, so x equals -2. E, state the coordinates of the y-intercept. Well, there's no quick way to find the y-intercept here besides plugging in 0 for the x value. So plug in 0 will give you the y-intercept. So instead of x plus 2 squared, it's going to be 0 plus 2 squared, which is 0 plus 2 is just 2. 2 squared is 4. So the y-intercept is 0, comma 5. F, Give the domain. Domain is always the same, negative infinity to infinity. G. Give the range. Well, the range in this case, if we look at my little sketch over here, it's something like this. The lowest point is 1 and the highest point is infinity. So the range is from 1 to infinity. H, you can just refer to the graph on the answer key because that did not work for me last time when I tried to graph it. So you can refer to the graph on the answer key. Now, to find the solution here, or to find the zeros or the x-intercepts for letter I, is actually very similar to how we find the, It's actually very similar to how we solve when completing the square. So what we're going to do is we're going to set the y equal to 0. We're going to set the equation equal to 0. And then there's a lot of things that we could do, but the easiest way to do this is square root method. So subtract the 1. So negative 1, and we're looking for the solutions here. X plus 2 squared. So I'll square root both sides to get rid of the square. Don't forget the plus or minus. So I get plus or minus I equals, because square root of negative 1 is I, x plus 2. I'll subtract 2. So my solutions, x is equal to negative 2 plus or minus I. There are two solutions, negative 2 plus I and negative 2 minus I. Those are two solutions. So this is all the information for number 2. You can use this information to graph it, and you can look at the graph at the answer key for letter H. Number 3, y is equal to 2x squared plus 8x plus 6. All right, letter A. Opens up or down. The A value is 2. The B value is 8. The C value is 6. So it opens up because the A value is positive. Letter B. State the coordinates of the vertex. So the vertex, the x-coordinate is negative b over 2a. So that's negative 8 over 4. This is negative 2. So the x-coordinate is negative 2. To find the y-coordinate, we'll substitute that into the equation. So you got y is equal to 2, negative 2 squared, plus 8 times negative 2, plus 6. So 2 times 4, minus 16 plus 6. So that's 8 minus 16 plus 6, which is negative 8 plus 6, which is negative 2. So we got negative 2, negative 2 as the vertex. This opens up like this, means the vertex is going to be at the bottom. So letter C, the vertex is a minimum, and the minimum value is negative 2, because it's always the y-coordinate for the minimum value. So it's negative 2. Letter D, give the equation for the axis symmetry. That's the x-coordinate, so negative 2, x equals negative 2. Letter E, state the coordinates for the y-intercept. The y-intercept is always the C value when it's in standard form, so 0, 6. But you could easily plug in 0 for the x's and get 6 for the y-intercept. Letter F, give the domain. Domain is all real numbers for every quadratic. G, give the range. Well, if we look at the graph here, the lowest point is negative 2 and the highest is infinity because it goes up forever, so the range is from negative 2 to infinity. H, graph, you can refer to the graph on the answer key. And letter I is to find the solutions. Alright, so there's a lot of different ways to find the solutions for this problem. So what we're going to do, first of all, when you're finding solutions, you're setting the equation equal to 0. So we're looking at 2x squared plus 8x plus 6 equals 0. We could use the quadratic formula. I'm not going to. but I'm either going to use completing the square or factoring, and I'm going to try to factor first. So I'm going to divide by 2 to get x squared plus 4x plus 3 is equal to 0. I can see that this will be factorable. Okay, so the quickest way for me to do this will be to factor it, but I could use the quadratic formula, could also use completing the square. So up top is positive 3, and the bottom is positive 4. The numbers I'm looking for are positive 3 and positive 1. So this factors into x plus 3 and x plus 1. So that tells me that my solutions are negative 3 and negative 1. So my zeros are negative 3, negative 1. These are also my x-intercepts. These are my roots, these are my solutions, these are my x-intercepts. I could have also done this problem completing the square, or I could have used the quadratic formula. But factoring was easier, so I just did that. All right. Number 4. Number 4 is in vertex form. Negative x minus 1 squared plus 4. This is in vertex form. Letter A. Is this opening up or down? Well, the negative sign out front is the A value. A is negative, so this opens down. B. The vertex. Well, the vertex, since this is in vertex form, h and k, h is 1 because x minus h, and k is 4, so my vertex is 1, 4. C. This opens down. This means it looks something like this. This means the vertex is a maximum, and that maximum point is 4. D. The equation for the axis of symmetry is just the x-coordinate, so x equals 1. E. The y-intercept. So for the y-intercept, I'm going to actually have to plug in 0 for x. So let me do y is equal to negative, and then 0 for x, so 0 minus 1 squared plus 4. That's negative. 0 minus 1 is negative 1, and negative 1 squared is 1. Notice the negative sign still on the outside. That should stay there. And then that's 3. So the y-intercept is 0, 3. The domain, all real numbers, of course. G is the range. The range, we can see that the highest point is 4, the lowest point is negative infinity because it goes down forever. So the range, lowest to highest, negative infinity to 4. H, refer to the answer key for the graph. And then I, to find the zeros, I will solve this equation. So I'll set the equation equal to 0. So 0 equals negative x minus 1 squared plus 4. And I'll solve this using square root method. So I'll subtract 4. Negative 4 equals negative x minus 1 squared. Alright, before I can take the square root, I am going to have to get rid of this a value. So I'm going to divide by negative 1 to get rid of it, which is going to give me 4 equals x minus 1 squared. And now that the a value is gone, now I can square root. Don't forget plus or minus. So this becomes plus or minus 2, and the right side is x minus 1. So I'll add 1. So my solutions are x is equal to 1 plus or minus 2. So my solutions, 1 plus 2, which is 3, and 1 minus 2, which is negative 1. So those are my x-intercepts, those are my solutions, those are my roots, those are my zeros. All right, and I did that using square root method. That's number 4. All right, number 5. So number 5, we're using this formula, or this equation. Negative 16t squared plus 40t plus 1.5. Number 5 says, how long will it take the ball to reach its highest point? So when we think about our function, our x and our y, our x is time and our y is height. So if we're looking for the highest point right here, we're looking for the vertex. And the x-coordinate will tell me how long it takes to get to that point, and the y-coordinate will tell me how high that point is. So first, number 5, how long will it take the ball to reach that point? I'm looking for the x-coordinate of the vertex, which means that I'm using the formula negative b over 2a, because this is a standard form equation. So negative 40 over negative 32 and that's 1.25 seconds. Since we are working with, this is the only time we'll use decimals, is when we're working with real-world problems. So since we're working with real-world problems, we are okay to use decimals, but this is the only time. So 1.25 seconds is how long it takes to get there. Now for number 6, I want to know the maximum height, the h value, so that means I'm going to plug or substitute this 1.25. So negative 16, 1.25 squared, plus 40 times 1.25 plus 1.5. Alright, so I'm going to simplify this. 1.25 squared times negative 16 is negative 25, plus 40 times 1.25, this is 50, plus 1.5. So the maximum height, 50, 25, 1.5, 26.5 feet. So the maximum height here, 26.5 feet. So after 1.25 seconds, it will be at its maximum height, 26.5 feet, and that is numbers 5 and 6. All right, number 7. Number 7 through 14 says to find the roots by factoring. So first set the equation equal to 0. So let's get this 24 on the other side, 24x. So we got 4x squared minus 24x equals 0. Let's factor out the GCF. GCF is 4x. So 4x comes out. We're left with x minus 6 equals 0. So that means I have two solutions. Each factor provides a solution. X equals 0 because 4 times 0 is 0. And then x equals 6 because 6 minus 6 is 0. So my two solutions, or my two roots, or my two zeros, 0 and 6. This could have also been solved using completing the square. Could have also been solved using the quadratic formula, but it says to do factoring, so I did factoring. Number 8, 9x squared minus 6x equals 0, so it's equal to 0. I'm factoring, so I'll factor out the GCF, which is 3x. So 3x comes out. I'm left with 3x minus 2. Alright, so I want to know what x value makes each of these equal to 0. So x equals 0 is one of the solutions because 3 times 0 is 0. For this other one, I want to know what x value, how to make this 0, so I'll solve the equation 3x minus 2 equals 0. Unless I can look at it and tell that the solution is 2/3, I need to do it this way. So I can add 2, divide by 3, and I see that the x value that makes the second factor equal to 0 is 2/3. Alright, 2 over 3, because 3 times 2/3 is 2, and 2 minus 2 is 0. So 2/3 will make the second factor 0. So those are my two solutions. 9, 49x squared is equal to 36. First of all, it needs to be equal to 0, so let's get the 36 over here. So I got 49x squared minus 36 equals 0. This is a difference of two squares. This is 7x and 6, 7x squared and 6 squared, which means that this factors into 7x plus 6, 7x minus 6. And the value that makes this equal to 0 will be negative 6 over 7. If you set this equal to 0, you'll get negative 6 over 7. And this factor gives us positive 6 over 7 as a solution. If you set this equal to 0, you'll get 6 over 7. So these are our two solutions. And remember, to get those, you solve the equations 7x plus 6 equals 0 and 7x minus 6 equals 0. Number 10. X squared minus 10x, minus 10 equals negative 3x. Alright, so I'll move the 3x to the other side by adding it. So I get x squared plus 3x minus 10 equals 0. I'm solving this by factoring. The GCF is 1, so I don't need to worry about the GCF, it's 1. Up top is negative 10, a times c, and the bottom is positive 3. So I'm looking for positive 5 and negative 2. Since a is 1, I can skip the grouping part and I can use these as my factors. So the factored form would be x plus 5 and x minus 2, which means my solutions negative 5 and positive 2. (11) 3x squared equals 75. This one says to solve by factoring, but there's no reason to do that. Let's just solve this by square root method. Factoring, I don't even know why this one would be. What's 70? Yeah, I guess it can be solved by factoring. But if you come across a problem like this, it's much easier to solve it by square root method. But I will go ahead and solve it by factoring. So I'm going to move 75 over, which is going to give me 3x squared minus 75 equals 0. I'm going to factor out the GCF, which is 3. So x squared minus 25. I see that x squared minus 25 is a difference of two squares, x and 5. So that means it can factor into x plus 5 and x minus 5, which means that each of these factors gives me a solution, negative 5 and positive 5. And if you had just used square root method, you would have gotten that same answer. 12, x squared minus 8x equals negative 16. Move the 16 to the other side. X squared minus 8x plus 16 equals 0. You should at this point recognize that this is a perfect square trinomial. Alright, if you take half of negative 8, you get negative 4, and negative 4 times negative 4 is 16. So you should know that this factors into x minus 4 squared. Which means this only has one solution that goes along with the one factor, which is 4. So 4 is our solution. 4x squared plus 14x is equal to 8. Let's move the 8 to the other side. So 4x squared plus 14x minus 8 equals 0. Let's factor out the GCF. GCF is 2. So 2 comes out. We have 2x squared plus 7x minus 4. So now I need to factor this, which means setting up the x. Now since a is 2, I do have to do this the long way. I have to factor by grouping. So up top I have a times c, so 2 times negative 4 is negative 8. In the bottom I have b, which is positive 7. So the numbers I'm looking for are positive 8 and negative 1. The product of these is negative 8. The sum of these is positive 7. So that means that I can split this up, 2x squared plus 8x minus x minus 4. And I can group these two, and I can group these two, and I can factor the GCF out of each group. GCF of the first group is 2x. GCF of the second group is negative 1. If I factor 2x out of the first group, I'm left with x plus 4. If I factor negative 1 out of the first group, second group, I'm left with x plus 4. So my factored form is 2x minus 1 and x plus 4. So this would be my final factored form. 2x squared plus 7x factors into x plus 4 and 2x minus 1. So this would be the factored form. Each of these provides me with a solution. This one provides me with the solution negative 4, and this one provides me with the solution 1/2. And remember, you find those by setting them equal to 0 and solving those equations. So 2x minus 1 equals 0 means x is 1/2. X plus 4 equals 0 means x is negative 4. Negative 6x squared plus, so number 14, negative 6x squared plus 7x plus 3 equals 0. The GCF is 1, so there's nothing to factor out there. Actually the GCF is negative 1, my mistake, because the first term is negative. So we need to factor out a negative 1. So I'll factor out a negative 1. I get 6x squared minus 7x minus 3 equals 0. Now I want to factor this. A is 6, B is negative 7, C is negative 3. So up top is A times C, 6 times negative 3, which is negative 18. And the bottom is B, so negative 7. The two numbers I'm looking for are negative 9 and positive 2. Their product is negative 18. Their sum is negative 7. So that means I can split the middle term. So I have 6x squared minus 9x plus 2x minus 3. I can group the second two and the first two together and factor the GCF out of each of them. So the GCF for the first group is 3x. The GCF for the second group is 1. And I'll have the same thing left over in both groups, which is 2x minus 3. So this factors into 3x plus 1, 2x minus 3. So I'll go back over here, and I have negative 1, 3x plus 1, 2x minus 3. Alright, so each of these factors provides me with a solution by just figuring out what x value makes them equal to 0. And I have a solution negative 1/3, and I have a solution 3/2. And those are my two solutions to the problem, or the two roots, the two zeros, etc. Alright, 15. 15, write a quadratic equation in standard form that has the roots 0 and negative 3. So each one of these provides me with a factor. This provides me with the factor x, and this provides me with the factor x plus 3. And these two multiplied together should be 0, since these are the zeros. To get this into standard form, I just need to distribute. So I have x squared plus 3x is equal to 0. And that is my equation in standard form that has the solutions, or the roots, 0 and negative 3. 16, same thing. I want an equation in standard form that has the solutions negative 2 and 4. So negative 2 provides me with a factor of x plus 2, and 4 provides me with the factor of x minus 4. And those two together should multiply to make 0. I'm going to use the distributive property to put this into standard form. So x times x is x squared, x times negative 4 is negative 4x, 2 times x is 2x, and 2 times negative 4 is negative 8. Combine the like terms. X squared minus 2x minus 8 equals 0, and I have my equation in standard form that has the solutions negative 2 and 4. Number 17, this is a cycle of i's problem, so I to the 17th power. So the cycle of i's, I to the first, or a remainder of 1, is just I to the second is negative 1, I to the third is negative I, and I to the fourth is 1. So this would be a remainder of 1, a remainder of 2, a remainder of 3, and then a remainder of 0 based on division by 4. So if I divide 17 by 4, I get 17 divided by 4, I get 4.25. 0.25 is a remainder of 1. So this would just simplify to I. Number 18, I to the 67th power. 67 divided by 4. So it's 16.75. So that's a remainder of 3. So that is negative I. 19, I to the 179. So 179 divided by 4. 44.75. That's a remainder of 3, so it reduces to negative I. 20, I to the 88. 88 divided by 4 is 22, which is 22.0, which is a remainder of 0, so it just simplifies to 1. And 21, I to the 1034. 1034 divided by 4. 258.5. So 0.5, that means remainder of 2, negative 1. Alright, 22. These are operations with complex numbers. So we have 6 minus 7i plus negative 8 plus 9i. Okay, so this is an addition problem because we're adding. So we just add the real parts and add the imaginary parts. So 6 plus negative 8 is negative 2. And negative 7 plus 9 is positive 2i. (23) 3 plus 7i minus negative 2 minus 6i. Subtraction problem. So we're subtracting the real parts, subtracting the imaginary parts. So 3 minus negative 2, which is 3 plus 2, so 5. And then 7i minus negative 6i, so 7 plus 6, which is 13, 13i. So 5 plus 13i. 24, 9i times 8i times I. We multiply this together. 9 times 8 is 72. I times I is I cubed. But if we remember our cycles of I to the third power is just negative I. So this becomes negative 72i. (25) 2 minus 5i and 3 plus I. So this is multiplication, which means we're going to have to use the distributive property. So let's distribute here. 2 times 3 is 6. 2 times I is 2i. Negative 5 times 3 is I is negative 15i. And negative 5i times I is negative 5i squared. But negative 5i squared, I squared is just negative 1. So this becomes plus 5. So we combine the real and the imaginary part. So 6 plus 5 is 11. And 2i minus 15i is negative 13i. 26, 3 plus 2i times 3 minus 2i. I can already tell that the product here is going to be a complex, or is going to be a real number because these are complex conjugates. So I'm going to distribute. 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is 6i. And 2i times negative 2i is negative 4i squared. But I squared is negative 1, so this is just positive 4. The 6i and negative 6i cancel, so I have 9 plus 4, which is 13. So number 26 is 13. 27, 3 over 7i. This is division, so I need to multiply by the complex conjugate, which is negative 7i. So I multiply the top and bottom by the conjugate of the denominator. So on the top I got negative 21i, and on the bottom I have negative 49i squared. But I squared is just negative 1, so this is negative 21i over 49. And that would be as pretty much as simplified as I can go here. 28, 2 plus I over 1 minus 4i. So this is division, which means I need to use the complex conjugate of the denominator. So I'm going to multiply the denominator by 1 plus 4i and the numerator by 1 plus 4i. So I'm going to have to use the distributive property. 2 times 1 is 2. 2 times 4i is 8i. I times 1 is I. And I times 4i is 4i squared. 1 times 1, so I have to do it again to the bottom here. 1 times 1 is 1. 1 times 4i is 4i. Negative 4i times 1 is negative 4i. And negative 4i times 4i is negative 16i squared. Now a lot of this stuff is going to reduce here. Like for instance, negative 4i and positive 4i cancel. Negative 16i squared is just positive 16. 4i squared is just negative 4. So on the top I can combine the real parts, 2 minus 4, which is negative 2. I can combine the imaginary parts, 8i and 1i, which is 9i. On the bottom I have 1 plus 16, which is 17. And now, last step, split the denominator so that I have the real and imaginary parts. So I have negative 2 over 17 plus 9 over 17i. 29, solve for x, and it looks like we're looking at square root method here. So 2x squared plus 32 equals 0. Let me subtract 32. So 2x squared equals negative 32. Divide by 2. So I got x squared is equal to negative 16. Square root both sides. Don't forget the plus or minus. So x is equal to plus or minus 4i. 30. X squared plus 45 is equal to 0. So subtract 45. So x squared equals negative 45. Square root both sides. Don't forget the plus or minus. So x is equal to plus or minus I root 45. 45 can be simplified though, because 45 is 9. 45 is 9 times 5, and we can do the square root of 9. The square root of 9 is 3, so it's 3 root 5. So this is actually plus or minus 3i root 5. Find the values of x and y that make the equation equal. So 5x plus 1 plus 3 plus 2yi equals 2x minus 2 plus y minus 6i. Alright, so the real parts need to be equal to each other. and the imaginary parts need to be equal to each other. So we have two equations. 5x plus 1 equals 2x minus 2. And the other equation, 3 plus 2y equals y minus 6. So I'm going to solve these two equations. So move the x's onto the other side. So I got 3x plus 1 equals negative 2. Subtract 1. 3x equals negative 3. Divide by 3. X equals negative 1. So for the real parts to be the same, x needs to be negative 1. For the imaginary parts to be the same, subtract y. So I got 3 plus y equals negative 6. Subtract 3. So for the imaginary parts to be the same, y needs to be negative 9. Number 32, solve by completing the square.